Good morning and welcome to the video for Monday, August the 3rd. This is going to be a video for our upcoming 5th graders. And with me today I have Ernie, who some of you may remember from some of the videos in the spring. This is our dog that lives with our in-laws, who is a greyhound and also a Great Dane. And usually he's pretty energetic, but it looks like he wants to take a nap right now. So he's here to help me out today. Today we're going to be looking at some geometry stuff, and then there will be a follow-up video on Thursday, and that will be the last video for this summer. I'm going to start transitioning to making videos to get ready for the coming school year. So one of the things that we're going to look at late in the school year will be working with identifying whether or not polygons are regular or not regular. And so we can go ahead and say that this is going to be a hexagon. So we would go ahead and put that. And then we have different markings. And so all of these markings for the sides say that they are all the same length. If we had two different lengths of sides, we might see a 1 for the ones that are even here, and then a 2 mark for the ones that are equal to each other but a different length. So we see the same thing with the rectangle here. And so that's going to be the extra thing that we look at, or one of the extra things that we look at when we're working with polygons. So this would be a hexagon that is a regular polygon. And then our rectangle is never going to be a regular polygon, because to be a regular polygon, we have to have all the sides and the angles to be the same measurement. So this one meets that requirement. This one has all 4 angles the same size because they're right angles, but the sides are different lengths. The next thing I want to look at really quick is triangles. So in 4th grade, we started with this idea of classifying triangles by their angles. And so a right triangle is always going to have 1 right angle. An acute triangle is going to have 3 angles that are all less than 90 degrees. So we would say that we would use this word here. So we have 3 acute angles. Acute means that they are smaller than 90 degrees. And in 4th grade, we took a protractor to go ahead and measure the angles to figure out what the lengths or measurements of those are. And an obtuse angle is always going to have 1 obtuse angle, which would be larger than 90 degrees. So to add to that, we are also going to classify triangles based on how many of their sides have equal lengths. And so an equilateral triangle is going to have 3 congruent sides, 3 sides that are the same length. An isosceles triangle is always going to have 2 congruent sides, and then a scalene triangle has 0 congruent sides. All 3 sides are the same length. Usually, if we have a scalene triangle, there's a really good chance that we also have a right triangle. So 3, 4, 5 ends up being an example of that, even though they didn't draw that. And we can find out the lengths of these sides if one of these was missing for a right triangle using a math formula that we'll use, I believe, in 6th grade. So the other thing I want to look at are 3-dimensional shapes. And so this will all be new, kind of. You'll have been familiar with some of it, like you can tell what a sphere is or a cone or a pyramid, but the way that we're going to talk about it is going to be a little bit different than what you have seen in the past. So our prism is always going to have 2 polygons that are the same size. So for instance, for our rectangular prism here, we can say that the top and the bottom are going to be the bases. There are sometimes that we would say that the left and right hand side are the base, but we'll take a look at that in just a moment for a specific type of shape. So for instance, actually we could do that here. So let's say that we turned that 90 degrees, and so the left hand side and the right hand side would represent our bases, even though they're not the top and bottom as we're looking at it. Same thing if we rotated basically any of these shapes except for these two. If we were, I'm pointing at the screen, if we took the shape and rotated it this way to where they were on the sides, that would still be the base. So our base shape for this one would be a rectangle. We have a prism, so that we would say that this is a rectangular prism. This one would be pentagonal because it's got 5 sides. This one would be 1, 2, 3, 4, 5, 6, so it would be a hexagonal prism. And then this one would be an octagonal prism. So that part's really easy. It gets a little bit more tricky when we're working with doing math to figure out the area, which is actually one of the things we'll be looking at on Thursday. So the last thing I want to do is look at a few of our other things. So pyramids are going to work similarly. We do have the possibility for having more than one type of base. So here we have a triangular base. Here we have a rectangular or square. Actually, this one would probably be a square pyramid. And then our last one would be a pentagonal pyramid. And then a cone is always going to have a circular or spherical base, and then a pyramid kind of point to it. So most of you are familiar with that with looking at ice cream cones. Our cylinder, which is a normal shape for a can, or for instance, this particular glass, which I probably need to not have in here, need to go wash it, as I'm not using it right now. Those would be examples of cylinders. And then a sphere has no bases, and one whole curved surface around the entire shape. So an example of that would be a basketball, a globe, baseball, tennis balls would also work. So to look at these really quickly, this one is going to be a pyramid because we only have one base. So we would have a rectangular pyramid here. This one would be a sphere. This one would definitely be a pyramid. And it looks like we have 1, 2, 3, 4, 5, 6 sides. So that would be a hexagonal pyramid. This one is going to be a prism. We have a base on the top and the bottom. They're equal sides. And then, so we would have a pentagonal prism here. We'd have a pentagonal pyramid. And then we would have a cylinder here. So those are the things I want to go over with for today. Again, on Thursday, there will be a follow-up video that's going to look at ways that we will use math to figure out the overall volume of one of those three-dimensional shapes. And that's the last thing that we'll take a look at before the school year starts. Hope your summer's going well. Hope you have a wonderful day. And I look forward to seeing you in the next video on Thursday.